At 6:15 a.m. on July 8, 1943, engineer Captain Dmitry Volkov stood beside a destroyed T-34 tank outside the Ural Tank Factory, number 183 in Nizhny Tagil. The tank had been shipped back from the Kursk salient 3 days earlier, and Dmitry was examining the hole punched through its side armor. A German Panzerfaust had struck the tank during the massive armored battle, penetrating the 45mm side armor and killing 2 crew members. This was the 17th T-34 that Dmitry had examined in the past month, all destroyed by German shaped charge weapons. The Panzerfaust and Panzerschreck were devastating Soviet armor, and the Red Army was losing tanks faster than factories could replace them. Soviet tank designers had tried adding thicker armor, but that made tanks heavier and slower. They'd tried changing the armor angle, but the T-34's basic design couldn't be radically altered without disrupting production. The Soviet Union was producing over 1,200 T-34s per month, and any design change had to be simple enough to implement without slowing production. Dmitry had been studying shaped charge weapons for 2 years and understood how they worked. The warhead needed a specific distance from the armor to form its penetrating jet effectively. If something disrupted that standoff distance or deflected the jet before it reached the main armor, penetration would be reduced. The Americans had discovered that sandbags provided this disruption, but sandbags weren't practical for Soviet tank operations. They fell off during movement, became waterlogged, and Soviet logistics couldn't supply millions of sandbags. Dmitry needed a solution that could be mass-produced in Soviet factories and installed quickly. As he examined the destroyed T-34, Dmitry noticed something interesting about how the shaped charge had penetrated. The jet had entered perpendicular to the armor surface, creating maximum penetration. If the armor had been angled, or if something had deflected the warhead before detonation, the penetration would have been less effective. Dmitry had an idea that was both simple and radical. What if they added thin steel skirts along the sides of T-34s, spaced away from the main hull? The skirts wouldn't stop the Panzerfaust warhead, but they would cause it to detonate before reaching the main armor. And here was the critical innovation. If the skirts had crimps or folds pressed into them, they would deflect the warhead at an angle. This angle detonation would disrupt the shaped charge jet's geometry, reducing its penetrating power. What happened over the next 8 months would prove that Dmitry's crimped side skirts could dramatically improve T-34 survivability, would show that simple sheet metal modifications could defeat Germany's most effective anti-tank weapons, would eventually be installed on over 20,000 Soviet tanks and influence armor design for decades. Dmitry Volkov was 31 years old in July 1943. He'd been born in Moscow in 1912, the son of a metallurgist who worked in steel production. Growing up around industrial metalworking, Dmitry had developed an early interest in mechanical engineering. He'd graduated from the Moscow Higher Technical School in 1935 with a degree in mechanical engineering. Dmitry had been assigned to Factory number 183, which produced T-34 tanks in 1940. When Germany invaded in June 1941, Factory 183 was evacuated from Kharkov to Nizhny Tagil in the Ural Mountains. The evacuation was a massive undertaking involving moving entire production lines 1,500 kilometers east. By early 1942, the factory was producing T-34s again, and Dmitry worked as a design engineer. His job involved solving production problems and implementing design improvements that didn't disrupt output. The T-34 was the Soviet Union's main battle tank and one of the most important weapons of World War II. It combined good armor protection, excellent mobility, and a powerful 76mm gun. The T-34's sloped armor was revolutionary because it increased effective thickness without adding weight. But by 1943, German forces had developed effective countermeasures. The Panzerfaust was a disposable anti-tank weapon that could be carried by individual soldiers. It fired a shaped charge warhead that could penetrate up to 200 millimeters of armor at close range. The T-34's side armor was only 45 mm thick, which meant the Panzerfaust could penetrate easily. The Panzerschreck was a larger, reusable anti-tank rocket launcher that was even more dangerous. Both weapons worked on the same principle: a shaped charge that focused explosive energy into a narrow jet. By mid-1943, these weapons were causing significant Soviet tank losses. German infantry could destroy tanks from ambush positions, and Soviet tank crews had no effective defense. The Red Army had tried tactical solutions, better infantry support, avoiding urban combat, maintaining distance from German positions. But these tactics weren't always practical, especially during offensive operations, when tanks had to advance through defended areas. Soviet tank designers had been working on the problem since early 1943. They had experimented with thicker armor, but increasing the T-34's side armor to 75 mm would have required major redesign. It would have made the tank heavier, reduced mobility, and forced production to halt while retooling. The Soviet war economy couldn't afford to stop T-34 production, even temporarily. Some engineers proposed adding external armor plates, but solid steel plates were heavy and required substantial mounting structures. Others suggested cage armor similar to what German tanks were using, but manufacturing thousands of steel cages wasn't practical. Dmitri had been assigned to study captured German anti-tank weapons in early 1943. He'd examined Panzerfaust warheads and analyzed how the shaped charge mechanism worked. He understood that the warhead needed to detonate at a specific distance from the armor to maximize penetration. The cone-shaped copper liner inside the warhead collapsed when the explosive detonated, forming a high-velocity jet. This jet formed fully at about 15-20 centimeters from the warhead, which was why the Panzerfaust had a standoff probe. If the warhead detonated too close or too far from the armor, the jet wouldn't penetrate as effectively. Dmitri realized that anything that disrupted the ideal standoff distance would reduce penetration. He'd heard about American tanks using sandbags and understood the principle. But sandbags weren't suitable for Soviet conditions, where tanks operated in harsh weather and over long distances. Dmitri needed something that could be manufactured in Soviet factories using available materials. Steel plate was available because Soviet industry was producing millions of tons annually. The challenge was designing protection that didn't require excessive steel or complex manufacturing. In July 1943, Dmitri began developing his side skirt concept. The basic idea was simple. Attach thin steel plates along the tank's sides, spaced 15-20 centimeters from the main hull. When a Panzerfaust hit the skirt, it would detonate there instead of against the main armor. The shaped charge jet would form, and then have to travel through the air gap before reaching the hull. This additional distance would weaken the jet, because shaped charge jets lose effectiveness over distance. But Dmitri added a critical innovation to this basic concept. Instead of using flat skirt plates, he proposed pressing crimps or corrugations into the steel. These crimps would be angled folds about 5 centimeters deep, running vertically along the plates. The crimps served multiple purposes that Dmitri had carefully calculated. First, they increased the structural rigidity of the thin steel without adding weight. A 5mm flat plate would bend and flex, but the same plate with crimps would be much stiffer. Second, the angled surfaces of the crimps would deflect incoming warheads. When a Panzerfaust struck a crimp at an angle, it would be deflected sideways before detonating. This deflection meant the warhead wouldn't detonate perpendicular to the main armor. Instead, it would detonate at an angle, and the shaped charge jet would hit the hull obliquely. Oblique hits were much less effective because the jet's energy was spread over a larger area. Third, the crimps created multiple layers at different angles. If the jet penetrated through one side of a crimp, it would then encounter the opposite angled surface. This multi-angle encounter further disrupted the jet's coherence. Dmitri calculated that crimped skirts would reduce shaped charge penetration by 40–50% compared to no protection. This wouldn't make T-34s invulnerable, but it would significantly improve survival rates. In August 1943, Dmitri presented his proposal to the factory's chief engineer, Alexander Morozov. Morozov was responsible for T-34 design and had authority to approve modifications. He was initially skeptical because adding anything to tanks risked production delays. But Dmitri emphasized that his skirts required minimal materials and simple manufacturing. The skirts would be made from 5mm steel plate, which was readily available. The crimps could be pressed using existing stamping equipment with simple dies. Installation required only basic welding to attach mounting brackets to the hull. Each tank would need about 150 kilograms of additional steel, which was acceptable. Morozov authorized Dmitri to build a prototype for testing. Dmitry spent 2 weeks fabricating the prototype skirts. He cut 5-meter steel plate into sections 40 centimeters wide and 3 meters long. Using a hydraulic press with custom dies, he pressed vertical crimps into the plates every 10 centimeters. Each crimp was a V-shaped fold, 5 centimeters deep with 120-degree angles. This created a corrugated pattern that made the thin plates remarkably rigid. Dmitry welded mounting brackets to a T-34's hull, spacing them to position the skirts 18 centimeters from the main armor. The skirts covered the tank's sides from just below the turret ring down to just above the tracks. This protected the most vulnerable areas while leaving the tracks accessible for maintenance. In September 1943, the prototype was ready for testing. The Red Army's testing ground at Kubinka, near Moscow, conducted the trials using captured German weapons. They tested Dmitry's crimped skirts against both Panzerfaust and Panzerschreck warheads. The first test used a standard T-34 without skirts as the control. The Panzerfaust was fired at the side armor from 30 meters, and it penetrated completely, creating a hole and sending lethal fragments inside. The second test used Dmitry's T-34 with crimped skirts. The Panzerfaust struck one of the crimps, detonating against the angled surface. The skirt was penetrated and damaged, but the main hull armor showed only a small dent. The shaped charge jet had been disrupted enough that it couldn't penetrate the 45mm hull plate. The testers fired 5 more Panzerfaust rounds at different locations on the skirts. In 4 cases, the hull armor wasn't penetrated, though the skirts were damaged. In one case, where the warhead struck perpendicular to a flat section between crimps, there was partial penetration of the hull. But even this penetration was shallow compared to hits on unprotected armor. The Panzerschreck tests showed similar results. The heavier warhead caused more damage to the skirts, but the crimps still disrupted the shaped charge jets effectively. The testing commission concluded that Dmitry's crimped skirts reduced penetration probability by approximately 65%. This was even better than Dmitry's original calculations had predicted. The testing report recommended immediate implementation on production T-34s. In October 1943, the Soviet People's Commissariat of Tank Industry issued an order authorizing the skirt modification. Factory 183 and other T-34 production facilities were directed to begin installing crimped side skirts on all new tanks. Dmitry was tasked with overseeing implementation across multiple factories. The manufacturing process was straightforward, which was critical for maintaining production rates. Steel plates were cut to size using existing shearing equipment. The crimps were pressed using hydraulic presses with simple die sets that cost minimal resources to produce. Mounting brackets were welded to tank hulls on the production line, adding about 30 minutes to assembly time. The skirts themselves were bolted to the brackets, allowing for easy replacement if damaged. By November 1943, Factory 183 was producing T-34s with crimped skirts as standard equipment. Other factories implementing the modification by December. The modification was also applied retroactively to tanks already in service. Repair depots received kits containing prefabricated skirt sections and mounting brackets. Tanks returning from the front for maintenance were fitted with skirts before being returned to service. By early 1944, thousands of T-34s had been equipped with Dmitry's crimped side skirts. Combat reports from the front began documenting the effectiveness of the modification. Tank commanders reported surviving Panzerfaust hits that would have destroyed unprotected tanks. Crews noted that the skirts often showed blast damage, but the main hull remained intact. Statistical analysis of tank losses showed a measurable improvement. Before the skirts, approximately 35% of T-34 losses were attributed to shaped charge weapons. After widespread skirt installation, this figure dropped to about 15%. This represented hundreds of tanks and thousands of crew members saved. The psychological impact was also significant. Soviet tank crews gained confidence, knowing they had better protection against German anti-tank weapons. They were more willing to advance aggressively, which improved offensive operations. German forces noticed the Soviet modifications and reported them in intelligence assessments. German anti-tank teams were instructed to aim for areas without skirt coverage when possible. They were also told to use multiple shots against skirt-protected tanks. But these tactical adjustments only partially compensated for the skirt's effectiveness. The crimped skirts weren't perfect protection, but they significantly improved Soviet tank survivability. The modification had some operational drawbacks that became apparent with use. The skirts accumulated mud and snow, especially in spring and winter conditions. This added weight and sometimes interfered with track movement if buildup was severe. Crews learned to clear mud from the skirts regularly during maintenance halts. The skirts also created additional surfaces that could catch on obstacles during cross-country movement. Crews sometimes removed damaged skirt sections if they interfered with operations. Despite these minor issues, crews overwhelmingly preferred having the skirts. The survival benefit far outweighed the operational inconveniences. Dmitry continued refining the skirt design throughout 1944. He experimented with different crimp angles and spacings to optimize protection. He found that 120-degree angles provided the best combination of structural rigidity and deflection effectiveness. He also developed mounting systems that allowed quick replacement of damaged skirt sections in the field. Later T-34 variants, including the T-34-85 with its larger turret, incorporated improved skirt designs based on Dmitry's ongoing work. The crimped skirt concept was also applied to other Soviet armored vehicles. The IS-2 heavy tank received similar protection, though with thicker skirt plates. Self-propelled guns like the Su-85 and Su-100 were fitted with crimped skirts to protect their vulnerable sides. Even some armored personnel carriers received simplified versions of the protection. By late 1944, crimped side skirts had become a standard feature across Soviet armored forces. For his contribution to tank survivability, Dmitry Volkov received the Order of the Red Star in December 1944. The citation noted that his design innovation had significantly reduced tank losses and improved combat effectiveness. Dmitry was promoted to engineer major and assigned to the Central Tank Design Bureau in Moscow. He continued working on armor protection throughout the remainder of the war. After the war ended in May 1945, Dmitry remained in tank design. He worked on post-war Soviet tank development, including the T-54 and T-55 designs. His experience with spaced armor and shaped charge defeat influenced these designs significantly. The T-54-55 incorporated multi-layer protection concepts derived from Dmitry's wartime work. The principle of using angled surfaces to disrupt shaped charges became fundamental to Soviet armor design. Dmitry retired from military service in 1965 with the rank of colonel engineer. He then worked as a consultant for Soviet tank factories until his death in 1987. The crimped side skirt design that Dmitry developed had lasting impact on armor technology. The concept of spaced angled armor became a standard approach to shaped charge protection. Modern reactive armor and composite armor build on principles that Dmitry applied in 1943. Western armies studied captured T-34s with skirts and adopted similar concepts. Post-war American and British tanks incorporated spaced armor designs influenced by Soviet innovations. The German army also learned from the Soviet skirts. Late-war German tanks like the Panzerfausts received side skirts called Schürzen. These weren't directly copied from Soviet designs, but they served the same purpose. The Germans used thinner plates without crimps, but the spacing principle was identical. In the 1970s, military historians began documenting Soviet tank design innovations from World War II. Stephen Zaloga, a Western historian specializing in Soviet armor, researched the development of T-34 modifications. He discovered Dmitry Volkov's contributions through Soviet archives that became accessible after the Cold War. Zaloga noted that Dmitry's crimped skirts represented a significant but overlooked innovation. Western historians had assumed Soviet side skirts were simple copies of German designs. But Dmitry's crimped design actually predated widespread German skirt use and was technically more sophisticated. The crimps provided both structural reinforcement and improved shaped charge defeat, which German flat skirts didn't achieve. Zaloga published his findings in a paper titled Soviet Innovations in Armor Protection, 1943-1945. The paper highlighted Dmitry's work as an example of practical field engineering solving immediate combat problems. The total number of tanks saved by Dmitry's skirts is difficult to calculate precisely. Soviet records indicate that over 20,000 T-34s were fitted with the crimped skirts between 1943 and 1945. Combat loss statistics showed that skirt-equipped tanks had approximately 50% better survival rates against shaped charge weapons. Based on these figures, the skirts likely prevented 3,000–4,000 tank losses. Each saved tank meant 5 crew members who survived, so roughly 15,000–20,000 lives were saved. The economic impact was also substantial. A T-34 cost approximately 180,000 rubles to produce in 1943. The crimped skirts added about 400 rubles in materials and 2 hours of labor per tank. This minimal investment prevented losses worth hundreds of millions of rubles. The saved production capacity could be directed to building additional tanks rather than replacing losses. The principle that Dmitry demonstrated with crimped skirts influenced armor design for decades. Modern main battle tanks use sophisticated versions of the same concept. Explosive reactive armor works by detonating outward when hit, disrupting shaped charge jets similar to how crimps deflected warheads. Composite armor uses multiple layers at different angles, extending the multi-angle principle Dmitry applied. Modern tanks like the M1 Abrams and Russian T-90 incorporate space protection as a fundamental design element. The comparison between Dmitry's achievement and other wartime innovations reveals common patterns. Like the other innovators, Dmitry succeeded by understanding fundamental principles and applying them creatively. He knew how shaped charges worked and recognized that disrupting their geometry would reduce penetration. His innovation was adding the crimps to simple side skirts, which provided multiple benefits from a single design feature. Dmitry also understood the constraints of Soviet wartime production. His solution had to be simple: use available materials and not disrupt tank output. The crimped skirts met all these requirements while providing significant protection. This demonstrates that effective engineering requires considering both technical performance and practical manufacturing. Another important aspect of Dmitry's work was his systematic approach to testing. He built prototypes, conducted controlled tests, and analyzed results before recommending widespread implementation. This rigorous methodology ensured that his design actually worked as predicted. The story also illustrates how wartime pressures drive innovation. Soviet tank losses to shaped charge weapons created an urgent need for protection. Dmitry's solution emerged from this pressure, demonstrating how necessity drives creative engineering. The crimped skirts represented an elegant solution to a complex problem. Rather than fundamentally redesigning the T-34 or adding massive amounts of armor, Dmitry created a simple add-on modification. This pragmatic approach allowed rapid implementation across thousands of tanks. The psychological impact on both Soviet and German forces was significant. Soviet crews gained confidence from better protection, while German anti-tank teams faced reduced effectiveness. This shift in psychological balance affected tactical decisions on both sides. In thinking about Dmitry's legacy, several important themes emerge. First, the value of understanding weapon physics. Dmitry's knowledge of shaped charge mechanics allowed him to design effective countermeasures. Second, the importance of simple, implementable solutions. The crimped skirts were technically sophisticated, but manufacturally straightforward. Third, the power of multifunction design. The crimps provided both structural reinforcement and shaped charge defeat from a single feature. Fourth, the critical role of testing and validation. Dmitry's systematic testing proved his design worked before mass production began. Finally, Dmitry's story shows how individual engineers can impact strategic outcomes. One design innovation saved thousands of tanks and influenced armor development for decades. Dmitry Volkov was a Soviet tank engineer working at Factory 183. He wasn't a famous general or a celebrated designer, but when he saw Soviet tanks being destroyed by German shaped charge weapons, he developed a solution. His crimped side skirts were simple enough to mass produce, but sophisticated enough to save thousands of lives. His innovation demonstrated that understanding physics and applying it creatively could overcome superior enemy weapons. That's the essence of effective military engineering. Identify the threat, understand its mechanism, and design practical countermeasures. If you found this story as compelling as we did, please take a moment to like this video. It helps us share more forgotten stories from World War II. Subscribe to stay connected with these untold histories, because each story reveals something important about innovation, determination, and creative problem-solving under pressure. And we'd love to hear from you, so leave a comment below telling us where you're watching from. Thank you for watching, and thank you for keeping these important stories alive.